everybody, my name is Sophie. Welcome to our prelim standard maths lecture for April of 2023. I'm super excited to be here with you guys today. If you've had any experience with ATAR notes lectures in the past, today is going to be a little bit different than what you're used to. I'm going to run through those kind of changes and updates in a second, but I do just want to say a massive thank you to everyone who is here today watching online. I hope that you find today helpful and productive in terms of helping you stay on track with where you need to be with your study. But lo and behold, let's just get into what we're talking about today. So the first thing that I just kind of wanted to mention to you guys, which I'm sure you kind of already know based on the quite blaringly large logo right in front of you and all of the words surrounding the video that you're watching today, but you are watching an ATAR Notes lecture. So we are a nationwide company that specialise in providing HSC resources to Year 11 and Year 12 and some Year 10 students. We have resources covering pretty much every subject. So head to atarnotes.com/register to check out more. To kind of give you a bit of an overview, we have hundreds of downloadable study notes. We also run 4 lecture series a year. So we have January, April, July, and September lecture series. We have online Q&A and discussion forums. We have videos for engaging online revision, newsletters to stay in the loop and to keep you updated on what's happening, everything HSC. We have an ATAR calculator. We also publish articles with study strategies and tips that are super helpful to keeping you guys aware of the best ways to study and what the new developments are. And we also have heaps more just sitting on our website for you to go and have a look at. So like I said, head to atarnotes.com/register to find out more. The other resources that I did want to flag for you guys are our paid models. So what we do offer in terms of tutoring is elite online tutoring from our recent grads. We have 2 models here. So we have our private tutoring where you can have 60-minute sessions weekly, fortnightly, multiple times a week with a tutor one-on-one online, and they work on you with your specific subject needs and requirements. We also have our classes that run through TuteSmart as well, so a 90-minute weekly class for a bunch of different prelim and HSC subjects. And they run for 46 weeks from the day that, or our HSC classes run for 46 weeks, and our prelim classes run for the entirety of the year. So the Year 11 year. So we have our online tutoring. We have 2 paid models. So like I was saying, we have our our private tutoring and then our classes. And I would really recommend that you guys check all of that out. We also have our study guides. These are printed revision materials. You can have them printed with our study guide, so you can actually buy the book, or Ed Unlimited. They're all sitting there as well. And if you have a subscription to Ed Unlimited, you have access to all of our study guides in one place. It is a fantastic resource. Highly, highly recommend that you do check those out. So like I said, atarnotes.com/register to check all of this out. If you are interested in any of the private tutoring and class tutoring, I'd recommend checking out sooner rather than later to get yourself very much underway and prepared as you approach the end of Year 11, because it does sneak up on you very, very quickly. I know it's only March, but I am going to kind of not scare you guys, but just give you a healthy warning of how quickly the next 2 years are going to go. One last thing, we just wanted to give a special thanks to La Trobe University, RMIT, Deakin, UTS, and Macquarie for helping us put these lectures on for you guys. So how will this lecture work? If you have attended any of our lectures before, if you were attending our January series, you may have known that it was a live lecture. And we were here live with you for 2.5 hours. So this time we're doing it a little bit differently. And this is to kind of curb any technical difficulties, make sure it's an engaging experience for you guys, both when you watch the live premiere and if you need to come back to the video. So it's striking a bit of a healthy balance there. So it's a pre-recorded lecture with a live chat. So I am not live with you guys today. I cannot currently see what you're writing in the chat, but I am in the chat. I am monitoring the chat. So the lecture is going to run for 2 hours. You can ask, and we used to run for 2.5. We're going to be running for 2 hours today. You can ask a question by using the chat. Obviously, this current version of me is not going to answer your question. I am just going to be running through the lecture, but I will be active in the chat to answer your questions today. I would also recommend downloading the slides. You can do this at any time, and it's useful if you move at a different pace to me, or you move a little bit slower and would like to go back to questions rather than staying up to date where I'm at, or if you would like to work ahead, you're also welcome to do that. What I would recommend is trying to stay relatively up to where I am in the lecture so that you get all of the bits of the explanation rather than working ahead or behind to your speed. So I would, like I said, recommend try to stay up to date. If you want to come back to the lecture, you can always come back because the video will be available after the lecture. So you can come back, revisit the parts you didn't understand. So try to stay generally up to speed today. So what are we covering today? By the end of today's lecture, we will have looked at perimeter, area, and volume from the measurement topic, interest and depreciation from the financial maths topic, units of energy and mass from the measurement topic, and classifying and representing data from the statistical analysis topic. So we always get questions like, why aren't you covering, all of this from algebra? Or why aren't you covering all of stats or something like that? We're very restricted on what we can cover in 2 hours. And because we do these lectures 4 times a year, we want to make sure that we spread the content out over those 4 lectures. So this is just what we're covering today. I would say we're going into some of the more difficult pieces of content, which is good because these are the ones that I still get questions on from my year 12 students now. So even as they get into year 12 and they get towards half yearlies and trials, they still have questions about energy and mass particularly. And also I would say perimeter, area, and volume from our 2 measurement topics. So it's good to try and nail these basics now, or at least have kind of 70 to 80% of the content understood now, rather than you trying to relearn all of this next year. I do want to point this out. When it comes to maths is a bit unique in the HSC. It's the only subject where you're explicitly tested on year 11 content in year 12. So you are not just tested on what is taught in the HSC, you are tested on about 15 marks of year 11 content. Now, why I mention that is because it's not something that happens in any other subject. No other subject, from my knowledge, will test you on prelim content explicitly. But 15 marks of your HSC exam in October of 2024 is going to contain content that I am likely talking to you about today. So it's really, really important that you understand this content now, because when you get to October next year, it's quite the task to go back and relearn year 11 when you could just do a good job now of understanding it, carry that knowledge into year 12 and not have to come back and consistently revise year 11. Hopefully that makes sense. Just wanted to make sure, yes, that I'm not getting any notifications during this. Okay, so a breakdown of the lecture, just a kind of an idea of where we're going to be today. I'm going to talk to you a little bit about me, just so you have an idea of where I'm coming from and who's speaking to you today. We're going to talk about how we study for maths, how do we approach maths exams, and honestly assessments as well, because there are going to be 1 or 2 maths assessments in the next year or so. Then we're going to go through content block 1, which is going to be measurement, perimeter, area, and volume, and financial maths, interest and depreciation. Then we're going to go through content block 2, which is going to be measurement, units of energy and maths, and statistical analysis, classifying and representing data. Then we're going to wrap up. We're going to do some last minute questions in the chat while I talk you through some last minute common questions I get and some tips and stuff that I generally find students talk about at the end of lectures. If you've been to our January lecture, you would have known that there used to be breaks. There won't be any breaks in this live premiere. So it is a 2-hour lecture, which is fine. I think everyone's done a 2-hour lecture at some point. You'll do them at uni. So I would encourage you to try and sit through it. If you obviously need to pop off for a quick, snack or to run to the bathroom, whatever, that's fine. You do you. And you can always come back to the video, but it will be a straight 2-hour lecture. I won't run through anything particularly quickly though, so you will have time to kind of go through the questions nice and slowly. So a little bit about me. I graduated in 2020. I went to Bethany College in Hurstville. I had an ATAR of 95.60. I studied English Advanced, Standard Maths, SOR 1, Modern History, History Extension, and Society and Culture. When I was in year 11, I also took ancient history and extension English, and then I dropped both of those subjects to go down to 9 units and then picked up history extension to go back up to 10. So quite a lot of subjects in there. If you are struggling with what you've chosen and you're feeling like, you definitely know what you want to drop, that's good. If you are sitting above 10 units and you've been told not to go down to 10 units when you go to year 12, I would kind of, say do a little bit of your own research and see how you feel about going down to 10 units. Personally, I'm a big proponent of 10 units, but it has to work for you. Just a little mention there. Feel free to drop questions in the chat about how those units work, and if I can answer them, I will answer them. So standard maths ended up being my best subject. I did get a band 6 in it. And I don't remember my exact study score, to be honest with you, but it was definitely, well into the 90s. I'm studying currently a Bachelor of Arts Laws at UNSW. Great degree, great uni. If you do have questions about uni, students often ask questions about uni, you can drop them in the chat. If I have time, I'll get back to you via the chat. But it's good that, because it's recorded, I won't have to kind of fill today with little uni questions here and there, but feel free to put them in the chat if you are so inclined. I have a beautiful German Shepherd named Luna. Sometimes she barks during my lectures, and I just want to apologize up front for that if she does. I would say teacher's pet in a cool way, in a relaxed way, in a engaged in my studies way. But I put that in there to kind of say that if anyone here feels like they are, very dedicated to their studies, or, are ever made fun of it for caring about it, it's cool to care. And as long as you care to a healthy extent, there is no shame in that. I also would guarantee I procrastinate more than you, and my dot point has moved up there. So if you have questions about procrastination, drop them in the chat. I get them every lecture because I mentioned I'm a big procrastinator. So feel free to ask me about them. I feel like I've got some healthy coping mechanisms. And then one of my non-academic tips for the HSC, this is obviously a little bit premature for you guys, but plan something amazing afterwards. I went on an amazing camping trip that was such an amazing 4 days and a great thing to look forward to, but you've got to sprinkle in little things to look forward to in the next 2 years, because sometimes the going gets tough and it's good to have things to look forward to. Okay, so let's talk about how we're supposed to study for maths. Before I do that, I'm just going to quickly, I have a terrifying fear that I'm not recording this 2 hours, but I am recording it. We're all good. How am I supposed to study for math? This is a question that is kind of complicated to answer, because the easy answer to give you is it depends. It honestly does depend. It's different for everyone. It's not something that can be answered with, a list of techniques, though I'm about to give you a list of techniques. And it's something that you kind of have to figure out on your own. What works for you? Here are a couple things that I would recommend are very important to consider and may work for you. Some of these are kind of non-negotiables, like the first, and some of them are definitely kind of up to your own preferences. First thing I would say is start now. It will be much less overwhelming if you do some of the groundwork early on. You guys are in the perfect place to start now. It's so important that you nail these concepts now, or you at least nail them 70 to 80%, because if you don't, the work you have to then do next year is pretty overwhelming. So I would say starting now is going to make such a difference, and it's not a heavy start now. It's just a stay on top of your work, do the best you can, make some small notes, and just do what you need to do through year 11 to end in a good place, rather than being a student who, and this happens to a lot of students, there's no shame in it, but you don't want to be a student who fails all of their prelims, which is what happened to a lot of people I knew. They failed all of their prelims because year 11 was so overwhelming that they weren't able to get on top of the work, and then you're going into year 12 with kind of a bad taste in your mouth, right? You failed all your prelims, you don't feel confident about your marks, you don't feel confident about your performance, and you're going in with a bad mindset and with a, less than desirable track record in year 11. Year 11 is the time to make mistakes. It's fine to fail things. It's just about how you recover from them. Failure is normal, but how are you going to recover? And I would say starting now is going to preemptively prevent that failure later this year from occurring. The next thing I would say, which is the most important in terms of note-taking, because note-taking for maths is very different than other subjects, keep a rule book. So this is a separate notebook where you can summarize important concepts, note down any tips or tricks that your teacher shows you. At the end of each topic, you can also write a summary page. I was a summary page student, so it was like a one-page, this is the summary sheet that you get in the HSC, but a one-page handwritten document that would say, linear relationships, and it would just have each of the dot points, say it was like y equals mx plus b, find the gradient, what is the y-intercept, and I would just have small notes under them, and they were mostly diagrams, drawings, little graphs, things that made sense to me. And when I would do topic tests or practices, I would use those summary sheets to inform my working out. And that way, once I got to the exam, I didn't need them. The only thing I would have would be the actual Year 12 standard maths summary sheet that they give you in the HSC. This is on your desk when you walk into the HSC exam. So summary sheets are really, really good because they're an active way of taking notes. We can think about note taking in active recall and passive recall. So it's no help to you. It's passive recall if you open your maths textbook and read through the notes, right? How are you learning anything from that? It just goes in one ear, out the other, or through the eyes and out the back of the head. When you do active recall, which is actively going through the content, choosing the pieces to memorize and writing them on a summary sheet, you are actively engaging with the content. So it's super important that that is how you try and tailor your summary sheets and your rule books, is through this mode of active recall where you actively engage with the content. The next tip, and this is again really important, is figuring out what you need help with and targeting it. So I had a bit of a difficult time with this particular point. I used to, so like simultaneous linear equations, where you have two linear equations and you have to work them out so they match. I really like doing those because I kind of understood them pretty early on, and I thought they were quite satisfying to do. And I distinctly remember sitting in the library at school in Year 12 and knowing that I still did not understand bearings, but choosing to review simultaneous linear equations instead, because it was A, easier to me, and B, I knew I was going to get them right. So I could kind of be like, well, I got all my questions right today, so I'm on the right track. I still didn't understand bearings or trigonometry. I couldn't do it. You have to choose the content that you don't understand and target it. If you don't do that, you're making a raw deal with yourself. You're spending your time on things that you're not struggling with, and you're setting yourself up to fail those questions in the exam. So you need to be a little bit strict with yourself. Take the content that you don't understand and prioritize it. It doesn't mean you never study the stuff that you understand. It just means you have to separate it out. Okay, so if you've got, 20% of the content is the stuff you struggle with, it's the Pareto rule. 80% of your study should target that 20% that you struggle with, because you're going to lose 80% of the marks on that 20%, if that makes sense. So it's really important that you figure out what you need help with and target it, and don't try and create study for yourself that is based on things you already understand in order to avoid the content you don't want to learn. It's very, very important that you target what you do not understand. The fourth thing is that there's always going to be somebody who can help you. Number one, your teachers are literally being paid to help you, and they are being paid to answer questions. So please go to your teachers as your first point of call. If you don't find that you're getting answers that you need, or you're struggling to understand the content based on your class or your engagement with your teacher, see if there's other teachers at your school, or even better, students that understand the content that you can go to. Next, online tutoring and classes are a great resource. Go to TuteSmart, find out what you need help with, and see if you can achieve that through tutoring. If it's maths, you absolutely can. We're absolutely going to be able to help you with anything maths. I know that as a guarantee. Fourth thing, go online, look at resources. Have a look at the Ed Unlimited books. Google for summary sheets or for example working out. Google questions you don't understand. There's always going to be a resource that can help you. Studying with friends. Now, this is one of those ones that I would heavily say this is dependent on who you are, who your friends are, and how you work. I had a good situation with studying with friends in terms of the way I did it, but I wouldn't say it works for everyone. The pros, they are the only other people who understand what you're going through and how hard it is, or what the content is that you're learning. And the HSC does depend on your whole cohort. So it's good when you all do well, right? The other side of that is that they are the most likely people to distract you, chances are. So it's important that you strike a healthy balance of studying alone and studying with friends, and you don't kind of convince yourself that I did this, I'm guilty, that going to the library and talking to them for 3 hours and opening your laptop and, typing a couple notes is studying. It's fine if you do that every once in a while. No one's going to, come and, punish you for it, but you just have to be strict with yourself. One thing that really worked for me was, and this is because I was in Year 12 when COVID started, so I was in Year 12 in 2020. So I had a very normal Year 11, and then we were online for a couple months in Year 12. What I would recommend is what me and my friends used to do, which is if we were studying and we really didn't, were struggling to focus, I would FaceTime my friends, put them up next to my laptop, and we would just study in silence. I would be able to see my friends studying. I would be studying in silence. Every now and then we'd ask each other questions or check in, or, if I, wanted to listen to some music for 10 minutes, we'd have a little dance break or whatever it was. But putting them on FaceTime really helped because it felt like someone else was studying with me. You can also do this via YouTube. So if you look up Study With Me or Pomodoro Study With Me videos, there's a bunch of people just recording themselves studying, and I really like them because it's like you're studying with a friend, but they're not going to distract you. Very, very much recommend. The final thing I would say is to take care of yourself. The next 2 years are going to be very intense academically, but it's very important you don't neglect your mental and physical health as well. This is so much easier said than done. It is so easy to slip down bad kind of patterns in terms of how you look after yourself and what you prioritize. If you do not sleep in the next 2 years, your marks are going to go down about 30%. I can guarantee that. Sleep is so important. So it is much, much more important that you go to bed at 11 rather than doing an extra hour of work till 12. That extra hour of work is not going to beat out what you could have had if you had that extra hour of sleep. It's also really important that you don't try and overextend yourself. You don't have to do every extracurricular, every part-time job, every sport. You don't have to do everything. You just have to get through it. And you will get through it, and you'll be very proud of yourself at the end, but it's important that you get through it whilst taking care of yourself. That to me is a bigger achievement than getting through it with one extracurricular or one extra, sport or something like that. On top of that, you also have to decide what your goals are. Do you want a band 4? Do you want a band 6? Do you want to just get through it? Do you want to get into a specific degree? It's entirely a personal endeavor. And just because the person next to you wants to get into a 99.9 course at Sydney Uni and you want to go and do, a 70 course at a different uni, that is great. That's perfectly fine. And it's good that you have a goal that works for you. It doesn't matter what other people's goals are. And truly, comparison will be the thief of joy. You have to stick to your own personal goals and your own personal levels of achievement and what you're looking to achieve. It is not going to help you to compare yourself to other people. And I tell you that as someone who has heavily compared themselves academically since the day they started kindergarten. It is not going to help you, and losing that habit is so, so beneficial. I would not recommend it more. So now we've made it to our content. So we're going to start with measurement, but I did want to say, pop it in the chat just to give me in the chat an idea. What topic would you say you struggle with the most? So we have measurement, financial maths, and stats. Just let me know. It's just interesting to see. I will spend, equal amount of time on all of them. So don't stress if you worry that one of them is much more your weak point. You can always come back to it. We're going to start with M1.2 in the syllabus, which is perimeter, area, and volume. So this is the part of the syllabus. I'm just going to give you a second to read it. So we're looking at a couple different things here. We're looking at practical problems, Pythagoras, scale factor, surface area of solids, prisms, cylinders, spheres, and composite solids, volume and capacity of solids, same thing, units of volume and capacity, perimeters and areas of irregularly shaped blocks of land, the trapezoidal rule, and then just those variety of context questions. So how do we do this in a bunch of different ways in real life applications? Okay, so we're going to run through a couple definitions to start us off. First things first, what is perimeter? So perimeter is the distance around the boundary of a closed figure. Area is the size of a surface. So this is some pretty basic stuff that I think you guys would already know. If we take a look at this, I've got my little laser pointer, this shape here. If we'd add these four sides together, we'd have the perimeter. If we multiplied this side by this side, we would find the area. Pretty basic stuff. This is super, super important. It's why it's in a beautiful red box. These are our formulas for perimeter and area. Now, if you take a look at our summary sheet, I think it's flipped to you guys, you'll see we have length, area, surface area, and volume on our summary sheet or our formula sheet. We have 1, 2, 3, 4, 5, 6, 7, 8 formulas, right? They don't tell you what these formulas are. It just says L equals theta over 360 times 2 pi r. It's your job to know what that means. These are the formulas with the object of the formula in front of the equation. So rectangle equals length times breadth, parallelogram base times height, triangle half times base times height, rhombus half times product of diagonals, kite is half times product of diagonals as well, trapezoidal rule or trapezium, half times height times sum of parallel sides, which is also h over 2 brackets df plus dl. We'll get into that in a minute. Circle, pi times radius squared, sector, fraction of the circle, theta over 360, times area of a circle, circumference, pi times diameter, or 2 pi radius. These absolutely need to be known. These are required knowledge. Sometimes they give them to you in the question, not all the time. So it's very, very important that you know these formulas. How are you going to learn them? Putting them on flashcards is great, whatever. It's just practice, honestly. Doing the questions over and over again is how you're going to get these formulas into your head. So I would highly recommend practicing questions with these rather than just trying to memorize them on a kind of rote learning basis. So you don't need to write them down on, little sticky notes and read your formulas out to yourself every morning before school. You just need to do practice questions. That is how you're going to learn these. I would recommend, I'm going to give you a second, I'll move my little laser pointer. Screenshot this or save the slide or whatever it is, because it's very, very important that you come back to this. Okay, so here's another helpful one because it's sometimes students forget, what is a diagonal, what are the diagonals or what does a kite look like? So take, for example, fraction of a circle. This one, you would be looking for 270 over 360 because you've got 3/4 of the circle. Height times divided by 2 times sum of diagonals. This is a trapezoid. We'll talk about this in a minute. And it's important to remember diameter is just the perimeter of the circle. So this is all surface area. These are our 2D shapes. So measurement, find the area of the shape pictured. So we have the area of a triangle, half times base times height. So how are we going to work this out? Because it's a right angled triangle in terms of, we have our right angle here. It's an easy equilateral triangle. It doesn't require any trigonometry knowledge. Half times base times height. So we're going to do half times our base, which is 8, times our height, which is 6, and let me get out my calculator. We get 24. Now, what helps you is understanding what formulas are doing. So what this formula is doing is saying, okay, if I had a square or a rectangle that had a base of 8 and a height of 6, that would be the area, right? But because it's a triangle, see how we could make the same triangle if we added this side and this side together? So it's telling you that half of the circle, which is where the triangle is, 8, 6. So the answer for this one, 24. Also got that written down. All right, so this is Pythagoras' theorem. A squared plus B squared equals C squared. So long ago, this magical Greek man realized that if you did the square of the two shortest sides added together, you would get the square of the longest side, which is the hypotenuse. So how do we apply this? We have the two shortest sides, 5 and 7. The longest side is always going to be opposite the right angle internally. So this only applies to right angled triangles. You cannot do this on non-right angled triangles. We'll get to that when we do more complicated trigonometry in year 12, which I believe you also do in year 11. But for now, it's very important that the hypotenuse is always opposite the right angle. So this theorem states that the square of the two shortest sides of that triangle are equal to the square of the longest side. So very simply, step number 1, you have to identify your two shortest sides, which are going to be next to the right angle. Hypotenuse, opposite the right angle. Then we just do 5 squared plus 7 squared equals C squared. So this is going to be 25 plus, oh, hang on, is that right? Yeah, 25 plus 7 squared, which is 49, equals the root of C squared. So 25 plus 49 equals 74. We have to square root that. and we get 8.6. So if we take a look at the answer, there we go. 5 squared plus 7 squared equals 74. 74 square rooted is 8.6 centimeters. Now, I forgot to write centimeters, very important, because then they go, what do you mean, bananas or something like that? You do always have to write the unit. It's a very, very, very important part of the equation. Okay, scale factor. So scale factor is a factor that we use to compare the size of two different shapes. So this is more of a real life analysis or application of a principle of mathematics. So for an example, if these triangles are in the scale 2:1, what are the measurements of the smaller triangle? So scales are read in what we call ratios. So this part is something to this part. It's saying that the first part is 2 times bigger than the second part. So if this is 2 circles, the second part would be 1 circle. So this triangle is twice as big as this triangle. So we just have to half all of the edges or all of the sides here. So it would be 5, 4, and 3, which are under those letters, as you can see there. If it gets more complicated, you might have to divide by like 3.5, or you might have to times by 7, whatever it is. But you just have to be able to read the scale. If it said the triangles are in the scale 1:2, which obviously doesn't look like it, you would have to double. So you do 20, 16, and 12. Okay, so we're going to move on to finding the surface area of 3D objects. So for prisms and pyramids, we add together the area of each side because these are mainly rectangles, squares, and triangles. So if we have a triangular prism that looks like this, well, that's not too bad of a drawing, you would have 3 sides, 1, 2, 3 rectangular sides and 2 triangular sides, right? So you're going to add the 2 triangular sides, so 2 of these together, and then you're going to have 3 rectangles that connect them, and you're going to add those together. So then you'd have 2 triangles, 3 rectangles, add them together, and you get the surface area of your prism. For other solids, we actually have formulas. So for a cylinder with 2 open ends, this is our toilet roll. It just looks like this. Oh, you know what I mean. Let me find you a cylinder with 2 open ends. Here's a hair roller. 2 open ends, you can see through it. This is a cylinder with 2 open ends. Our formula is area equals 2 times pi times radius times height. Now we're going to conceptualize why this is our formula. 2 times pi is giving us, times radius, is giving us this, times height is giving us how far down it goes. And that's our area, because we just need this piece that wraps around. Cylinder with 2 closed ends is going to look like, here's a dry shampoo bottle. 2 closed ends, close on the top, close on the bottom. This formula is slightly different because we've got 2 times pi times radius squared plus 2 times pi times radius times height. So we're finding 2 times pi times radius squared is our 2 solid bases. We've got to find the area of 2 circles plus the same thing as up here. 2 times pi times radius times height, which is the bit that wraps around. The last formula to run you through is our sphere. Area equals 4 times pi times radius squared. So our sphere is going to, we always do a bit of shading to show that it's a sphere. Something like this is 4 times pi times radius squared. I don't exactly understand why it is 4 times pi times radius squared because it's kind of complex mathematics at this point. I'm looking around to show you a sphere. I think everybody knows what a sphere looks like, so we're probably good on that one. 4 times pi times radius squared. So let's go back to our formula sheet. 4 times pi times radius squared is there. Area equals 2 pi r squared plus 2 pi r height. Cylinder with closed ends. We don't get the formula for a cylinder with open ends. So we have to know that on this section where we get the cylinder with closed ends, that the cylinder with open ends, no 2 circles connecting, we would just have to cross out the first part of that formula. All right, so find the surface area of this prism. This one, we've already got the working out, but I'm going to walk you through it. So the first thing we're going to do is step number 1, what are our faces? We have 2 triangles and 3 rectangles. So we're going to work out our 2 triangles first. Because it's a equilateral easy triangle, we've got a right angle in the middle. We can just do half times base, 4 times height, 6. Now, because we have 2 triangles, you can either work that out twice and add them together, or you can just do 4 times 6. Because if you added these 2 together, you'd get the square or the rectangle you would have anyway. 4 times 6 is going to be 24 centimeters squared. Now we need to work out our 3 bases. We have 12 centimeters on the base times 7 centimeters on the side. So this is actually the incorrect, we have 2 different sides. We have to work out the base first. So this one is 4 centimeters. So 12 times 4 centimeters to find the base. And we get 48 centimeters. And then we have 2 higher rectangular sides. So 12 times our 7 side here. 12 times 7 times 2, because there's 1 here and 1 here. We get 168 centimeters. So if we add together 24, 48, and 168, our answer is 240 centimeters squared. Okay, so more formulas that you need to know. Volume, the amount of space that a solid occupies. Capacity, the amount of fluid that a container can hold. So space that a solid occupies. I'm looking around for an explanation. So these AirPods hold a specific amount of volume, right? They occupy a specific amount of space. Whereas this container can contain a certain amount of fluid. It has a capacity. Its capacity is currently fulfilled by highlighters and scissors, but I could fill this with water and it would have a capacity. So the volume of a prism. Prism, we're talking about what we were just talking about. So we've got our rectangular, that's a trapezoidal prism of some sort. We've got our triangular, we've got our prism that looks like this, something like that. Then we have, so that's face area times height. So literally if you took a knife, I'm going to attempt to draw a knife here, and you cut down the middle, if it was a triangular prism, you would just have something that looks like this, right? Say the area of this was 13 centimeters squared. It'd be 13 centimeters squared times whatever the height was, 8. And that would be your volume cubed. That is for prisms. Now for cylinders and spheres, we do a different formula. Cylinders, volume is pi times radius squared times height. So let's have a look at our formula sheet. Pi times radius squared times height. Not on your formula sheet. Volume of a sphere, 4/3 times pi times radius cubed. We do get that. 4/3 pi r cubed. It's the bottom one here. I always remember anything to do with the 4 is a sphere. Okay, so let's have a look through some more important information. Capacity and volume also rely on these conversions. Anything with this red around it, I would say you guys need to write down or highlight or, screenshot. So capacity and volume will rely on these conversions. 1 milliliter is 1 centimeters cubed. So if you have a milliliter of water, it is, if you were to pour it into a mold of centimeters cubed, it's going to be 1 centimeter cubed, 1 physical centimeter cube. 1 liter is 1,000 milliliters, which is 1,000 centimeters cubed. And 1 kiloliter is 1,000 liters, or 1 meter cubed. So let's take a look at this example. Find the volume of this triangular prism. So our volume is going to be our area times our height. So how do we do this? We just take our area of our face. So think of it like area of the face times height, which is 12 centimeters squared times 13. 12 times 13 is going to give us 156 centimeters, and this is the important part, cubed. And we'll see 156 centimeters cubed. Okay, it's also, like I said, important to express your volume in cubic terms. Okay, trapezoidal rule. This is something that is very, very important to understand. We use this rule to calculate the area of fields that don't have a straight boundary. So this could be like a farmer's paddock. It doesn't have a straight line, but rather a curved line on the edge. This is where his gate is. This is where he keeps all his sheep. This is his little house over here. Not a straight line, right? The area that we're going to come up with for a trapezoid is generally an estimate, which is why we have a rule that we use. So it's h over 2 df plus dl. This is horizontal height, so the thing running this way, in between the two sides, over 2 brackets, side number 1 plus side number 2. So don't worry about knowing what df and dl mean. Just remember side number 1 plus side number 2. Okay, we're not answering a quiz, so you can ignore that. But for this one, we can do this question. So it would just be height, which is 52 over 2. And our sides are 43 plus 76. Our answer would be 3,094 meters squared. You have to do the squared. Okay, find the perimeter of the following shape. We're just going to run through a couple practice questions before we move on to our next piece of content in 5 minutes. Perimeter of this is going to be 45 times 2, because there's 245 millimeters plus, and now look at our different measurements. Centimeters, millimeters. So let's do 4.5 centimeters times 2 plus 2.1 centimeters times 2. Now, why did I go to 4.5? Because there are 10 millimeters in 1 centimeter. So I can just pop a decimal place right there. I'm going to add these together. We get 13.2 centimeters. So 2.1, 2.1, 4.5, 4.5. Add them all together. We're now going to write out formulas regarding the calculation of area. I'm just going to show you guys these ones. So rectangle, length times breadth or width is also correct. Parallelogram. Now this is any shape that just has, now that would be a trapezoid, ignore that, 4 sides. So it can look like this, could look like this, could look like this. Any shape that has 4 sides that isn't one of our other, rhombus, kite, trapezium. Base times height, just generally speaking, base times height. Triangle, half times base times height. Now why is that? Because 2 triangles will fit inside the parallelogram. That would be base times height. So it's just half. Rhombus, half times the product of diagonals. These are diagonals. The lines that run diagonal to the edges. Kite, half times product of diagonals. Trapezium is our trapezoidal rule. H over 2 df plus dl. Circle, pi times r squared. Sector is the sector. So if we're looking for the sector of a circle and it tells us find the shaded portion, that would be 3/4 or 270 degrees over 360 times pi r squared. If we were asked to find this, it would be 90 over 360. All right, find the area of the following irregular shape. So let's first have a look at what we've been given. It looks like we've been given 2 triangles. So we're going to find the area of these 2 triangles. We're going to add them together. AC equals 22 meters. This middle line here is 22 meters. Area of a triangle, half times base times height. So let's do this triangle first. Half times our base, which is 22, times our height, which is 18. Because we could flip the triangle around and it would look like this, 18, 22. We pop that into our calculator. Half times 22 times 18, we get 198 meters squared. Our other triangle, half times 22 times 10, we get 110 meters squared. We add those 2 together, we get 308 meters squared. So it's important we just have the 2 triangles. These are what they'd look like if you drew them out. All right, using multiple applications of the trapezoidal rule, find the area of the figure below. So our trapezoidal rule, h over 2 df plus dl, or side 1, side 2. So you have 2 different trapezoids. First one, height 10. Remember our height's the bottom, horizontal, over 2, 28 plus 25. Pop that into our calculator. 10 over 2, 28 plus 25. We have 265 meters squared. Other trapezoid, second one, 10 over 2, 25 plus 31. We get 280 meters squared. If we added those together, we would get 545 meters squared. Surface area of this closed end cylinder. Okay, closed end cylinder is area equals 2 pi r squared to find our two circles plus 2 pi r height. So 2 times pi times our radius. This is a 20 centimeter diameter, so our radius is 10 centimeters. 10 squared plus 2 pi times 10 times what's our height? 13 centimeters. That all goes in the calculator. 2 times pi times 10 squared plus 2 times pi times 10 times the height of 13. We get 1445.13. Didn't tell us to the nearest decimal point, so I'm just going to put it to 2. Or we can put it to 1. 1445.1 centimeters squared. We're looking for surface area. Surface area of this prism. So when we're looking for the surface area of a circle, let's run back to our formulas because this is not one that they give you on the formula sheet. Sorry guys, takes a second. Okay, surface area of sphere. 4 times pi times radius squared. So remember, it's not the 4 over 3. 4 times pi times radius squared. So 4 times pi. What's our radius? Our diameter is 25. So our radius is half of 25, which is going to be 12.5 times 12.5 squared. Pop that in. We should get 1,963.5 centimeters squared. Very important. Diameter, radius is half. Okay, how do we smash measurement? How do we get full marks? Read every question very, very carefully. Take note of the units of the measurement, underline keywords, read the figures twice. Very, very important. Always double check your answer. So was it meters squared, meters cubed? Very, very important to make sure you're using the correct one. And always learn your formulas because they will not be given to you with the actual formula in it. So even if you go, okay, well, it's on the formula sheet. Do you know what 2 pi r squared plus 2 pi r h means? No. You need to remember your formula so you know what that formula means. Okay, what to include on your summary sheet. So these are all the things we've just run through. I've underlined the things that I find very, very, very consistently come up in year 12. So you need to know all your area calculations, your Pythagoras theorem, scale factor. Write down some examples of surface area of prisms, cylinders, spheres, and composite solids. Talk about volume and capacity, talk about conversions, talk about perimeters and irregular area, trapezoidal rule. Area calculations, Pythagoras, volume, capacity, trapezoidal rule are what I find come up the most in year 12 questions. So that's what I would emphasize in my revision. Not an actual claim there, not a statistical analysis of the exams, just in my experience. All right, we're going to move on to F1.1, which is interest and depreciation. This is the first part of our financial unit. This is the syllabus dot points. I'm going to give you a second to have a look at these. So you can see we're looking at percentage increase and decrease, simple interest, goods and services tax, depreciation. We've got a depreciation formula, and we're also going to have, there's also a mention of recurrence relations, not very important. All right, so some definitions. Percentage increase in financial, the percentage by which something will increase in value. Percentage decrease, a percentage by which something decreases in value. So if there's something's on sale, it's on a percentage decrease. If something's been marked up, it's on a percentage increase. GST is the goods and services tax. So everything that you buy has a 10% tax included called GST. It's just to basically tax the cost of goods and services. Simple interest is the interest that does not compound. So we're talking about interest using the formula I equals PRN. Interest equals principal times rate times number of time periods. Depreciation is when something will depreciate or decrease in value over time. When you buy a car, it often goes down in value over time. All right, so we're going to look at something that experiences a percentage increase. So this is a jacket that increases in price by 50%. So it originally cost $80. So to find the percentage increase, we add the percentage to 100% because 100% of 80 is $80, right? So if we want to go up by 50%, we have to do 150% of the price. We add our percentage to 100% already. We don't just times it by 50% because we get half if we did that. So the jacket has increased by price by 50%. It's now $120. So now we can do the opposite. The $80 jacket is now on sale. It experiences a percentage decrease of 25%. So we now minus 25% from 100, which would be $80, to find 75% of the value. So 80 times 75%, our value is now $60, which is 75% of the original $80 jacket, or a percentage decrease of 25%. Okay, simple interest. Very, very important you understand this formula. It's the amount of money that accrues based on how much money you put in the bank. So say you have $2,000, you give the bank $2,000. They're going to calculate simple interest, if that's what you elect to do, on that $2,000 in, indefinitely. So they're just going to keep doing it unless something happens in the investment, there's a closure period, whatever it is. They're always going to calculate interest on the original amount that you invested. So even if you add more money, the interest is still going to be calculated on $2,000. And even when you earn interest, the interest is still going to be calculated on $2,000. So it doesn't matter if the account gets up to 10 grand with all the interest you earn. It's still going to be calculated on $2,000. This is simple interest. So I equals interest. P is the principal or the money invested. R is the interest rate, which is usually expressed in a percentage or a decimal point. And N is the time period. So how many times over is the money going to be calculated, or the interest is going to be calculated. So Kayla invests $7,000 into a simple interest account for 3 years at a rate of 4% per annum. We always underline our 3 pieces of information: principal, number of time periods, rate. So now we plug that into our formula. $7,000 times a rate of 4% per annum. We're going to convert our rate to a decimal. It's easier to put that in like that. 0.04 times 3 years. We then get $840 of interest. That is not the value of the investment. That's how much interest the bank has paid her. Okay, so depreciation refers to something that is going down in value. I'm going to use Lightning McQueen here. Let's say he depreciates, this would never happen because Lightning McQueen would never depreciate, but let's say he depreciates in value by $450 per year for 3 years, starting at $70,000. So we have a formula here. Salvage value. So think of a car lot where they like salvage cars for parts. Salvage value, our final value after all of the depreciation, is going to be VO. Don't worry about the O, it's just V. Minus depreciation times number of time periods. So his original current value is $70,000 minus depreciation of $450 per year for 3 years. His salvage value, he's going to be worth $68,650 at the end of the 3 years. All right, we're going to do a couple practice questions now. So calculate the simple interest on the following investments. $4,000 invested for 6 years at 8% per annum. So to do this question, we have to do I equals PRN. So interest equals $4,000 times the rate, which is 0.8%, times 6 years. We put that in our calculator. We get $1,920 of interest. Next question. $2,800 is our principal, invested for 3 years at 0.025%, 3 years. 2,800 times 0.025 times 3 years, we've earned $210. This shows you the difference between interest rates, 8% versus 2.5%. Now, this one's important to understand. $7,800 invested for 5 years at 4%, calculated every 6 months. Number one, it doesn't say per annum, so we're going to understand this is a 6-monthly interest rate. If it was 4% per annum, calculated every 6 months, we would have to divide it by 2 to get our 2-monthly rate. But because it doesn't say per annum, we're just going to write 4%. Every 6 months for 5 years, so there's not 5 time periods, there's 10, because there's 10 lots of 6 months in 5 years. So 7,800 times 0.04 times 10. 7,800 times 0.04 times 10. And I get $3,120. Okay. We've got those notes there. Does not say per annum, 6 monthly, 5 years. All right, we now have a table of interest rates we're going to complete. So we've been given one interest rate for each of them. So we're going to try and work down from our first piece of information. So if the 6 monthly rate is 3%, we can assume that the annual rate would have to be double that, right? 6%. If the annual rate is 6% and we want quarters, we're going to divide by 4. 6 divided by 4 is going to be 1.5%. And if we want the monthly rate, we're going to divide 6 by 12, which gives us 0.5%. Now we have a monthly rate, 0.4%. We're going to divide by 4 to get 4 months, which is, by 3 to get 3 months, which is a quarter. So we get, hang on, I've got to go back to this one then. Let's see if I can erase. I've just realized I've done this one wrong. So we have an annual rate of 6%. Oh, actually, no, I think I did it right. We have an annual rate of 6%, quarters, 6 divided by 4, 1.5. And our monthly rate, yes, we need to go 6 divided by 12, so 0.5. Second guess myself for a second there. If we have a monthly rate of 0.4, we can divide it by 3 months to get a quarter, 1.2. If we have 0.4, we're going to divide by 6 to get 6 months, 2.4%. And then we divide that by 2 to get the annual rate, 4.8%. This one, annual rate 10%, so 6 monthly rate is going to be half of that, 5%. We then need a quarter of our annual rate, so 10 divided by 1 quarter is going to be, or 10 divided by, we can go, there's 4 quarters, so divided by 4, 2.45%. And then we want a monthly rate, so we can do 10 divided by 12, and we get 0.8%. Last one, if the quarterly rate is 4.5%, 4.5 times 4 quarters is going to be 18%, half that for our 6 monthly rate, and then 18 divided by 12 is going to give us our monthly rate. This is really, really important stuff to understand because so many of your questions will give you $7,000, 4% per annum, compounded quarterly. You need to break that 4% down into 4 quarters to get that 1% interest rate. If you don't make these changes when you practice these questions, you will not get the question right. We've got all of our answers there as well. Okay, a car is purchased for $45,000 and depreciates at $800 per year. How much is it worth after 5 years? Oh, ignore that. Okay, so we have our salvage value equals our current value minus depreciation time periods. Salvage value is going to equal $45,000 minus our period of depreciation, which is $800 per year for 5 years, so times 5. Pop that into our calculator. 45,000 times 800 or minus 800 times 5 gives us $41,000. Other question, a house is purchased for $1.2 million and depreciates at $18,000 per year. This is very uncommon for houses, but let's say the wear and tear is serious. 18,000, 20 years. 1.2 million minus 18,000 times 20. The house is now worth $840,000. Take a look at these questions. We have our two answers here. All right, we're also going to find the percentage increase from a couple of different amounts. So how do we find the percentage increase? We need to find the difference between the two as a part of the first. So $200 to $260. The difference here is $60. We need to find how much 60 is of 200. So 60 over 200 gives us 0.3, which means it was a 30% increase. Now we can test this by doing 200 times 130%, which gives us 260. Next one, the difference there is 4 meters. 4 over 10 is going to give us 40%. So our percentage increase was 40%. All right, 45 liters to 67 liters. We need to find the difference. 67 minus 45 is a difference of 22 liters. We have to divide by our original amount, 45. 22 over 45 is 0.48. So we're going to say a 48% increase. 53 minutes to 90 minutes. We're going to find our difference. 90 minus 53 is 37-minute difference. Divided by 53. 37 divided by 53 is 0.698. So I'm going to go 70% increase. We have all of our answers there. Oh, I've just realized my original answer was wrong. This is wrong. 53. But yes, all of our answers, 30, 40, 48, and 70. Correct. All right, calculate the GST included within the post-GST prices. So when we're finding GST, we need to, if it's currently got the GST in it, we have to take the amount of money that includes the GST, divide it by 11 to find that 10% tax. Because it's 10% of the original price, so there's technically 11 parts. So $670 divided by 11, 670 divided by 11 gives us 60.9. So I'm going to go $61. $321 divided by 11 is going to give us 29.18. So I'm going to go with $29. $38,096. 38096 divided by 11 gives me 3,463.27. And then 123.68 divided by 11, 123.68 divided by 11 is $11.24. So we'll just go with $11.24. So this is the GST added into these prices. So you can find the no GST, you can find the original price by going with the cost. So 670 minus GST would be the pre-GST price. Apologies for the very shoddy handwriting. Okay, over 7 years with an interest rate of 6.5%, $4,049.50 of interest is earned. Calculate the original amount of money invested. So our formula is I equals PRN, right? We now have the I, $4,049.50 equals principal Rn, which we know, if we actually write them in, is going to be, we're looking for the principal, calculate the original amount of money invested. We know that the rate was 0.065, and we know that it was over 7 years. So how are we going to do this? We're going to change the subject of our formula. The first thing I'm going to do is 0.065 times 7. So we know that it's this times 0.455. Now, if I want to move this to this side of the formula, I have to divide it by itself, which erases it from this side. We just get left with P, and we have to divide this by 0.455. So 4049.50 divided by 0.455 gives me 8,900 equals P. So the original amount of money invested was $8,900. Like that. All right, so how do we get all of our questions right? How do we smash interest and depreciation? Number one, read the question very, very carefully. Is the interest rate per annum, but the time period is months? You have to be able to pick out whether it says per annum, months, quarterly, daily, monthly, biannually, whatever it says. Always clarify what your final answer was. So were you asked to find the interest? Were you asked to find the investment plus the interest, the original investment? It's very important to double check that. And remember those interest and depreciation formulas. All right, what do you include on your summary sheet? Examples of percentage increase and decrease, GST, simple interest and straight line depreciation, and then compound interest as a recurrence relation. This is very rarely tested. That's why I didn't even bring it up to you guys, because it is literally just doing simple interest over and over again to figure out compound interest, which you'll do compound interest in year 12 anyway. These underlined parts very much are on the year 12 exams that I see. Okay, let me know in the chat if you're all doing okay. I'll answer any questions at this point. I'm going to keep talking now, but let me know if everything's working for you. You're all good. All right, content block 2. We're going to look at M1.3, which is units of energy and mass. Okay, so this is our piece of our syllabus, M1.3. We're going to look at metric units of mass in solving problems, including grams, kilograms, tons, and their abbreviations. Also looking at calories, kilocalories, joules, kilojoules, and their abbreviations. Food and nutrition questions. We're looking at the amount of energy expended in activities and the amount of energy used in the consumption of electricity. So we're looking at kilowatt hours and common appliances in terms of their energy consumption. All right, so little overview. When we talk about units of mass, we're talking about measuring different quantities. So volume, capacity, area, length, width, or weight, which is mass. So this is a diagram from my HSC notes. It has tons, kilograms, grams, and milligrams. And it showed me that if I want to go from milligrams to grams, I have to divide by 1,000. If I want to go from grams to kilograms, I have to divide by 1,000. Kilograms to ton, divide by 1,000. If I want to go down, tons to kilograms, kilograms to grams, or grams to milligrams, I have to times by 1,000. I would very much recommend drawing something that looks like this. Now my text has moved around, which is a bit annoying, but tons, kilograms, grams, milligrams. If you want to go this way, so if you want to go small to big, you have to divide. If you want to go big to small, you have to multiply. Now, I know this doesn't make sense because you think you're multiplying, you're getting bigger. The number should be getting bigger. But there are going to be a lot less zeros in tons than there are in milligrams, because milligrams are smaller and tons are bigger. Okay, so we're going to complete the following conversions. 0.37 tons to kilograms. So we've got 0.37 tons. We're going to times by 1,000. 0.37 times by 1,000 gives me 370 kilograms. 560 milligrams to grams, we're going to divide by 1,000 because the number should get smaller as the unit gets bigger. 570 divided by 1,000 is 0.56 grams. 670 kilograms to grams, we're going to times by 1,000. Times by 1,000. 670 times 1,000, we get 670,000 grams. and 370, 0.56, and 670,000. We're under there. Okay, energy, units of energy. Energy is measured in kilojoules, which is kJ, or calories, CAL. Super, super, super important that we understand this part. They use uppercase and lowercase letters to distinguish between two different types of calories. Cal, is in physics and chemistry. So when we're talking about units of energy that move things, it's kind of hard to explain. The one that you probably understand or are aware of is calories, uppercase C, which is the amount of energy in food. So when we talk about kilojoules and calories, there's a distinction. Cal versus lowercase cal. We also have kilojoule or joule. So let's have a look at some conversions. 1 kilojoule, think about it as 1 kilogram, is 1,000 joules or 1,000 grams. Think about it as an example of that. They're not related, but I'm saying 1,000 in 1, 1,000 in 1, very important. 1 calorie in energy, physics, chem, is going to be 4.184 joules. 4.184 joules, 1,000 joules, 1 kilojoule. Break down a kilojoule into 1,000 joules, break it down into 4.184 joules, you have 1 physics or chemistry calorie. Now, 1 calorie in food is 1,000 calories in energy, of physics and chem, You know this calorie. This is how many calories are in a piece of bread, right? Made up of 1,000 little calories. So look at the uppercase versus the lowercase. Equals 1 kcal. So we just know that 1 big calorie is the same thing as 1 kcal. They're interchangeable. So 1 calorie is 1 kcal, which is 1,000 little calories, which is 4,184 big joules, which is 4.184 kilojoules. If you write that down somewhere, it should help you keep track of these conversions. Okay, so we're going to convert the following. 14.36 kilojoules to joules. So if we know that 1 kilojoule is 1,000 joules, we're going to divide 14.36 kilojoules by 1,000. 14.36 times 1,000, we get 14,360. Now, if we do our next one, calories to joules, 1 little calorie, right, is 4.184 kilojoules, which 1 kilojoule is 1,000 joules. So we're going to go a couple different ways. 39 calories times 4.184 kilojoules. 39 times 4.184 kilojoules is 163.176 kilojoules. Now we're going to go to little joules by timesing by 1,000. So we times that by 1,000, we get 163.176. Now, one thing to make sure we do here is keep an eye on our capitals and our lowercase. 250 kilojoules to calories, uppercase. We know that 1 uppercase calorie is 1,000 little calories. So 250 kilojoules, we go, see, this still even confuses me. Let's see what I've written down. There we go. 200, oh, I see what we've done. So we've mixed up, this one should be uppercase because we've done uppercase calorie, 1 kcal, 2 kilojoules, 1,000 joules. I know this doesn't make a lot of sense. It's really a matter of practice. This one, 250 kilojoules, divided by 4.184. I think this has just been incorrectly typed. This should be in a capital. Yeah, that should be a capital. So 250 divided by 4.184, 59.75 calories. We'll do some practice questions that show you guys these a little bit clearer. Let's look at this question. 1 serving of chicken soup has 8.9 grams of protein, 11 grams of fat, 17 grams of carbohydrates, and 4.6 grams of dietary fiber. what is the total energy intake of the soup? Okay, so we've got a key down the bottom here. Energy intake, we're going to represent our energy intake in, let's see, we want to do it in kilojoules. So we have 8.9 grams of protein. We're going to times that by 17 kilojoules per gram. So 8.9 times 17 is 151.3. Now we need to do the fat. So we have 11 grams of fat, which is 38 kilojoules per gram. 11 times 38, we get 418 kilojoules. This is all in kilojoules. 17 grams of carbohydrates times the 17 grams kilojoules per gram. So 17 times 17 is going to be 289 kilojoules. And dietary fiber, there's 4.6 grams and it's 8 kilojoules per gram. 4.6 times 8. 36.8. Now we need to add all these together. 151.3 times 418, plus 418, plus 289, plus 36.8. We add all of that together. We get 895.1. Now we can see under there the same working out, 895.10 kilojoules. It's very important when you work out that you show each piece of working out, you add them all together, and do not forget to write your kilojoules at the end. Okay, we're going to answer this question. I'm going to give you a second to read it because it is a bit of a wordy question. All right, so consider the information below when answering the following questions. We've got that same breakdown, 17 kilojoules per gram for protein, 38 kilojoules per gram for fat, 17 kilojoules per gram for carbs, 8 kilojoules per gram for dietary fiber. Annalisa eats 2 eggs, 3 pieces of bacon, and 1 piece of toast for breakfast. She has 43 grams of protein, 52 grams of fat, 50 grams of carbohydrates, and 7 grams of dietary fiber. We need to find the energy intake. So first things first, protein, 17 times 43, 17 times 43, 731. 52 grams of fat, so 38 times our 52 grams, we have 1,976. We then have 17 grams per kilo carb, and we have 50 grams of carbs. 17 times 50, so 850 kilojoules, and then 8 kilojoules for dietary fiber, and we ate 7 grams of it. 8 times 7, 56. We now need to add 731 plus 1,976 plus 850 plus 50. We're going to have 3,607 kilojoules in this meal. Okay, we've got that. Oh, 3,000. What's different here? 8 times 7. I added 50 instead of 56. So go back and add 56. Yep, 3613. Sorry, guys. 3,613 kilojoules. Okay, now this is one that a lot of students get these questions very confused, and I'll break it down nice and slowly for you. A dishwasher uses 6 kilowatt hours a day. The energy is charged at 57 cents per kilowatt hour. What is the monthly cost of operation? So let's break this down. What is a kilowatt hour? Okay, every energy appliance, let's take a dishwasher, like we've been given. We can use a washing machine. We can use a stove, an oven. We can have, I'm going to draw you a bunch of appliances. We can have a fridge. We can have a kettle. Very poor attempt at drawing a kettle. They all use what we call watts. Watts are a unit of energy, right? Everything uses a specific number of watts every hour, and it will be available on the product description. Everything uses a specific number of watts per hour. Say something uses 200 watts per hour. We then break that down into kilowatt hours. So 1,000 watts is 1 kilowatt. So 200 watts is going to be 0.2 kilowatt, and then it uses it every hour, hours. So all you're doing is converting the number of watts used per hour into a kilowatt and adding an H onto the end. So if a dishwasher uses 6 kilowatt hours a day, it uses 6,000 watts a day. The energy is charged at 57 cents per kilowatt hour. What is the monthly cost of operation? So we're going to do 6 kilowatt hours times $0.57 to find the cost for 1 day. 6 times 0.57, $3.42 per day. Now, some students would times this by 30 or 31 for monthly. They may give you the answer, they may not. What you're meant to do is times it by 365 days to get the yearly cost. So the yearly cost is $1,248.30. And divide that by 12 to find a 12th of the year. Now I know I'm sitting under the video over here, so I'll rewrite it. 1248.3 divide by 12. Divide that by 12, and we get 1248.3 divided by 12, $104.025. So let's just say the monthly cost is $104. Now you'll see that we do the same thing in the working out, divide by 12, $104.03 a month. Okay, those questions are quite confusing, so if they don't make sense, pop some questions in the chat. Convert the following units of measurement. All right, we're going to do another one of these practice questions for conversions. 10 tons to kilograms. For tons to kilograms, we need to times by 1,000. So 10 times 1,000, we have 10,000 kilograms. All right, for kilograms to milligrams, we need to first divide 1560. We need to times, by 1,000 to get down to grams. 1560 times 1,000. That gives us 1,560,000. We're going to times that by another 1,000. There we go. Yeah, times by 1,000, which gives us, this is a lot of zeros, but I'll write them out for you. 156,000,000,000, which I believe, would be 1,560,000,000 milligrams. Okay, grams to tons, we're going to divide by 1,000 to get up to kilograms. So 6,009 divided by 1,000 is 6.09009 kilograms. Divide that by a further 1,000 to get up to tons. So it would be 0.006009 tons. 240 milligrams to grams, we're just going to divide by 1,000 once. 240 divided by 1,000 gives us 0.24 grams. Wonderful. All right, we've got all of that written out there. You'll see I also struggle with the decimal points, which is why it's best to just work from the back. All right, Andy consumes 9,345 kilojoules in a day. What is his caloric intake that day? So we know that that there are 4.184 kilojoules in a calorie in food. We're talking about caloric intake in terms of food here. So we just need to do 9.345 divided by 4.184 kilojoules. 9,345 divided by 4.184 kilojoules, and he's consumed 2,233.51 calories that day. Now let's double check what we've got here. Yeah, is a mismatch with our caloric. So if we were to answer that exact question, we would want to go to lowercase calories, but because we're assuming here we're going to joules first and then dividing by kilojoules, we can go, to 2233.51 calories. So this is an extra step, or we can just divide straight by 4.184. All right, a 400 watt television runs for 5 hours a day. The energy is charged at 42 cents per kilowatt hour. What is the total cost of operation per day? Okay, 400 watt television. When it says 400 watts, that's how many watts it uses per hour. 5 hours per day. 400 times 5 hours is going to give us 2,000 watts, which is 2 kilowatt hours a day. 42 cents per kilowatt hour, 2 times 42 cents is going to be 84 cents. We've got times 5 to get 2 kilowatt hours. Our cents times 2, $0.84 per day. All right, we have another caloric intake question here. Same information as before. Ben eats a chickpea salad for lunch. It contains 13 grams of protein, 34 grams of fat, 29 grams of carbohydrates, and 4 grams of dietary fiber. What is the total energy intake from this meal? So protein, we've got 13 times 17. We get 221 kilojoules. We have 38 times 34 grams of fat, which is 1,292. We have 29 grams of carbs times 17. 493 kilojoules, and 8 kilojoules of dietary fiber times 4. 8 times 4, 32. We add together 221 plus 1292 plus 493 plus 32. We have 2,038 kilojoules. Check our answer, 2,038 kilojoules. All right, how do we do particularly well in measurement when we're talking about energy and mass? Okay, for the 100th time, this is very, very important. You have to read all of your questions very carefully. If you don't see that there's an uppercase C or a lowercase c or a kilojoule or a joule or whatever it is, you are going to get the question wrong. It's very, very important. That's why I would say go through and highlight the parts of your question that are important to read the question very, very carefully. Keep an eye on the difference between calorie and calorie. Very, very important. Like I just said, uppercase calorie is more likely to be questioned because it's about food and nutrition. And practice your conversions. These conversions are going to save your life in certain questions that you don't understand or you don't know how to do. It's very important that you understand them by the time you get to the exam because they make up parts of questions that you wouldn't even expect to be part of units. So sometimes you'll be doing a stats question and you might need to do a conversion to figure something out. So it's very important that you understand all of your conversions despite whether you think you'll get questioned on them or not. All right, so what do you include on your summary sheet? You need to include your units of metric mass, so your conversions. These are the calories, kilojoules, watts, kilowatts, tons, kilograms, grams, milligrams, all of that. Energy conversions, calories and kilojoules, and electricity. So the units of metric mass conversions and electricity are what I see are questioned the most of students in Year 12. Okay, we have 30 minutes left and we're on to our final piece of content, which is our classifying and representing data, which is from S1.1, our first part of our statistics unit. So you'll see it's quite long. I'm going to give you a second to read while I catch my voice for a second. It is a long time to talk without stopping. Okay, so what are we doing? We're describing and using appropriate data collection methods for populational samples. We're classifying data relating to a single random variable. We are reviewing how to organize and display data into appropriate tabular and or graphical representations. And we're interpreting and comparing data by considering it in tabular and or graphical representations. Okay, how do we do all of this? Let's find out. There are heaps of different ways that we categorize data. So this is in our classifying data section. We're going to take a look at this diagram. So we start off with having a piece of data. Let's say we've interviewed a bunch of people about their preferred color of a car. We then have either categorical or numerical data. Categorical is about categories. So what's your favorite color of car is categorical. If it was how many kilometers would you prefer on the car you buy, it's numerical. So we have two distinct categories. You know what I mean? Categorical, these are things we can put into different categories. Numerical are number-based, so on and so forth. Then we go further down. So we end up with four different categories. So nominal categorical is when there is just different categories. So red car, blue car, green car, white car. Ordinal would be if there were categories that go in order. So say it's your grade, A, B, C, D, E. There's an order to those. Numerical discrete is a number that is a whole, so you can't be, there can't be 2.5 people. There's 2 people or there's 3 people. Continuous would be like your height. You could be 153.54721 centimeters, right? You can kind of go as far past the decimal point as you want. So characteristic divided into categories, numbers able to count, order of categories have an intrinsic order. So rankings versus something like eye color, car color, hair color. Discrete number, like a discrete, it has to be an exact number. So it's number of people, number of days in a week. You can't have 7.6 days in a week, there's 7 days in a week. Continuous, any numerical value within a range. So mass, you could be 61.547 kilograms. Okay, here are some ways that we collect data. So number 1, census. This is about collecting data about every individual in the whole population. So we have an Australian census that runs every 4 years from memory. And this is something that they might mention in questions sometimes. Sample is about collecting data about a portion of the population. So you might just want to collect a sample from year 12 students. A bias sample is data that has been unfairly influenced by the collection process. So it's not truly representative of the population. This might be if you wanted to interview people about how they felt about reality TV, but you only interviewed people who actually like reality TV. Kind of a biased sample. A self-selected sample is a voluntary response. So you choose to be a part of it. It might be fill out this survey about your local parks and it's just posted online and anyone can fill it out. Random sampling is when every member of a population has the equal chance of being selected. So it might be we're going to choose 5 people from this group of 50 people in this maths class. Everyone has an equal chance of being one of those 5 people. All right, stratified random sampling is sample made up of random samples taken from subgroups. So you might take 7 students from year 7, 6 students from year 8, 9 students from year 9, so on and so on. Stratified random sampling. Systematic sampling is when everyone gets put in order and then every certain number of person is chosen. So let's say you have a roll of people that are alphabetical and every 5th student is chosen to be part of the sample. So what is the correct classification of this data? The brands of toothpaste used by members of the population. So we have our data. Is it categorical or is it numerical? Brands of toothpaste is a categorical piece of data. Now, is it ordinal or is it nominal? Is there an intrinsic order is there an order like there are ranks, or is it just different categories? It is just different categories. So categorical, ordinal. Didn't let the answer up, but categorical, ordinal. So moving on from that, we're going to talk about frequency distribution tables. This is a tool we use to help us display data. This is what it looks like. We have the number of pets that people own, a tally of when we would take that survey and the frequency. This is how often somebody owns 0 pets, how often somebody owns 1 pet, blah, 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 on and on. Okay, couple points. Number 1, the classes, which are what we call this first column, the piece of information, cannot overlap. So you couldn't do 0 to 1 pets, 1 to 2 pets, 2 to 3 pets. Because if someone has 2 pets, which one do they go in? This one or this one, right? The classes cannot overlap. It would have to be, let's take this example, 10 to 19, 20 to 29. You cannot have overlapping classes. Even if a number has no data, like let's say 5 pets, there was no one, you still have to include it if it's in the data set. Each interval must also be the same size. So you can't do 0 to 1 pets, 2 to 6, 7 to 8. Everything has to be the same size. We see that in the example sitting there. So cumulative and relative frequency, what's this? Cumulative frequency is the sum of all of the frequencies of the scores. So going back here, the scores were our tally. So 4 people have no pets. 6 people have 1. 5 people have 2. 3 people have 3. 2 people have 4. Cumulative frequency is adding all of those together. So cumulative frequency for score 3 would be all of score 1, all of score 2, and all of score 3 added together to get up to 11, the cumulative frequency before the score you're talking about. Relative frequency is the number of times that a score occurs as a fraction of the total number of scores. So let's take an example, the relative frequency of 5. Well, 5 only occurs once, and there are 14 total scores. So 1 over 14 is a relative frequency of 5. We could also convert that to a percentage. So 1 over 14 is going to be 0.07, which is a 7% chance that you have a score of 5. Percentage relative frequency is that relative frequency as a percentage. So we do our relative frequency in a fraction and our percentage relative frequency as 7%. Dot plots. These are super, super simple. They are a physical, graphical, visual representation of where scores are represented. So this question was, how many minutes does it take you to eat breakfast? So 1, 2, 3, 4, 5, 6 people take no minutes, probably because they don't eat breakfast. 2 people take 1 minute, 3 people take 2 minutes, 5 people take 3 minutes, so on and so forth. This is what it would look like if you asked a question, how many people take 5 minutes? You would go 1, 2, 3, 4, 5. There are 5 people. If the question was how many people take more than 6 minutes, you would go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. 17 people take 6 minutes or more to eat breakfast. Okay, stem and leaf plots. I'm just giving you an overview of all of our different methods of displaying our data. You are literally imagining a stem and leaves like this. Nice little graph for you there, or drawing for you there. So this is our stem. Let's say our stem, we have, we can say our plant goes out there. We have 4 different stems. 1, 2, this is number 1, this is number 2, this is number 3, this is number 4. Each leaf is a little number. This is the leaf 1 and 1. Then we have 2 leaves that are called 2. 1 leaf called 3. 4 leaves called 4, so on and so forth. So all it's showing you is that this piece of data here is 10, 10, 10, 11, 11, 13, 17, 19. This is 63, 66, 52, 56, 57, 57, 58. So you're just adding these 2 numbers together to create a full number. So instead of having to write 52, 56, 57, 57, 58, you just write the 5 once. Hopefully that makes sense. So this is our stem. Every number on the left is attached to those on the right. Okay, we're going to do a quick refresher on column, line, and bar graphs. So how do we construct these? What are our rules? You always have to double check your horizontal and vertical axis. So is the correct data in the right spot and are they labeled? Second thing, make sure your scale starts at 0. If it doesn't start at 0, you have to do this little jump thing where you add kind of a squiggly line in there, and then you can start at 10. down here, sorry. You'd start at 10 here and this would be 20. You have to do a little squiggly line to show that that's happening. You should be able to see it on examples, but most of the time you should be starting at 0. Make sure the scale is regular. See how they all increase by the same amount of time? This one's always by a month, this one's always by 1, and this is always by 5. And it always has to go by the same amount on the same axis. So you can't switch it to like 5, 10, 25, 5, 10, 50. You've got to go by the same amount the entire time. These two don't have to match because they're going to be different variables. You also have to make sure the line is exactly following each point. So you can't draw 4 hamsters to here, right? Where it's like 4.7. You also can't draw January to February over here and then March is back here. You have to line them up with each piece of information. Also, when you have column or bar graphs, you need to leave a space between each bar, which has been done on each of these. Okay, a histogram. What is a histogram? Now, this is where spaces aren't necessary because we're looking at frequency histograms and polygons. A histogram is a graph, column, or bar, a column graph or a bar graph, in which the values of the variable are placed on the horizontal axis and the frequency of the variable is on the vertical axis. So these are the values. So let's say the question was, how old is each person? 34 to 40, 41 to 47, so on. This is how many people are in that age range. What it's doing is there is one person who is 34 to 40. No one is 41 to 47. 5 people are 48 to 54. We've drawn bars for each of those. Now we've done the number of people. Frequency polygon is how we then create a line graph out of that. So we join the midpoints of the top of the column of each column in the frequency histogram. So we start at the bottom left of the first column. We draw a line to the top middle. We then just draw lines to the top of each bar or column in our graph. And we end by going to the bottom right corner of our last bar or column. That is a frequency polygon. So the polygon is representing a line. Okay, this is a bit more complicated. See how we have, first of all, I want to point out our little jump here. So we jump to 20 and then we go 22, 24, 24, 24, 26, 28, so on and so forth. Cumulative frequency histogram is a histogram with cumulative frequency on the vertical axis. So this is saying, say our scores were one person had 22 centimeters, 3 people had 24 centimeters, 4 people had 26 centimeters. Our cumulative frequency by the time we get to 26 is going to be 8. So at 26, say we'd be at 8 if that was correct. So it's always going up. It's just the cumulative frequency of all of the scores added together. A cumulative frequency polygon would be if we had drawn columns on here and then we drew a line that followed all the upper right-hand corners. So if we just went like this the whole time through the upper right-hand corners, joining each column of the cumulative frequency histogram. Okay, Pareto charts. Pareto charts follow the 80-20 rule. This is a rule I was talking about earlier. Generally speaking, 80% of your marks in your HSC exam are going to come from 20% of the work you did. It's just a basis of the Pareto rule. Pareto charts follow this rule and say that 80% of something occurring is the fault of 20% of something else. So let's have a look. Defects in shirts. 80% of the defects are being caused by the culmination of button defect. So when we look at the number of defects and we follow this line, we want to say that the culmination of button, pocket, and half of the collar defects is 80% of the defects. So this is only feeding into that lower range. It's just about where our line goes. All right, we're going to look at a practice question now. Fill in the blanks below. Data that can be divided into categories would be categorical. Data that reflects numerical values will be nominal. If there's no order, it's categorical ordinal. If there is an order, it's categorical nominal. I know that it's kind of complicated, but stick with it. If there are exact values, it's numerical discrete. If it's no exact values, it's numerical continuous. Sorry, nominal is no order, ordinal is order. I went the wrong way around there. Okay, Have a look at another practice question. A company has the following demographics. 20 to 29, there's 134 employees. For people aged 30 to 39, there's 57. 40 to 49, there's 114. 50 to 59, there's 76. The company needs to survey 25% of the company. How many employees are taken from each subgroup? So we need to find what 25% of each of these are to find the total 25%. So we need to do 134 times 25%. Gives us 33.5, so we're going to round to 34 employees from this group. Then we need to do 57 times 25, which is 14.25, so we're going to round down to 14 employees. 114 times 25% is going to give us 28.5, so we'll round up to 29. And then 76 times 25% gives us 19 employees. So we need to take 34, 14, 29, and 19. 34, 14, 29, 19. This is a longer way of breaking it down that I wanted to show you guys. We break down into, this is 35%, 15%, 30%, and 20% of the company. So this is 100% of the company. We then just times 35%, which is how much of the company is in this portion of the population, times 95, because we need 95 employees, we get 33 employees. So we end up with the same answer, 33, 14, 29, and 19 equals the 95 employees. It's just a longer way of working it out. Okay, we're going to create a dot plot that represents the following data. Time taken to complete homework. So there's 15 minutes, 30 minutes, 45 minutes, and 60 minutes. So 5 students take 15 minutes. 7 students take 30 minutes. 9 students take 45 minutes. And 12 students take 60 minutes. So then we have a number of dots. It should be evenly spaced in terms of this one should be the lowest, then they should go up like that, but it's hard to do it on a computer, obviously. What is the average time taken to complete homework? So we'd need to find the average by adding them all together and then dividing by the number of time or the number of people involved. So 5 people take 15 minutes. So we've got 5 times 15. 5 times 15 would be 75. Then we've got 30 times 7. 30 times 7. Hang on, let me just think about what I'm doing here before I send you down a stupid path. Mm-hmm. 30 times 7. We've got 210 minutes. Let me save you this. 45. That's Luna if you can hear her. Times 9. 405. 60 times 12. 720. So we have an array of different amounts of minutes. What we're going to do is, how many students do we have? 5 plus 7 plus 9 plus 12. We have 33 students. We're going to divide our number of minutes by our number of students, which gives me 42 minutes. So we could say our average amount of time taken is 42 minutes, which would put us closest to our average 9 students who take 45. We've also already worked out that there are 33 students in the class. We can also see that there, 42.72 minutes. And that's a much, much nicer dot plot that I've drawn for you there. All right, observe the frequency distribution table below, filling in the cumulative frequency polygon. Okay, so let's fill out this column first, and then I'm going to show you what this looks like. All right, so, oh, actually, I'm not going to show you the cumulative frequency graph. That's another question. I just got myself confused. Score, 12 frequency for 1 to 9, so we're just going to write 12. Now there's 25 for this column, so we're going to add 25 and 12 together. 25 and 12 gives us 37. We're now going to add 32 to put us to the next column, which is 69. We're now going to add 18 to put us up to the next column, which is 87, and then a further 27 to give us 114. And we can see our answer there is correct. All right, answer the following questions by referring to the stem and leaf plot. Write out all the data points in order. Now, this is a little bit tricky to do with a mouse, so I'm going to put it on the next slide when we have the answer. So let's have a look. What is the average score? To do this, we need to add all of the scores together and then divide by the number of scores. So 10 plus 13 plus 16 plus 21 plus 26 plus 27 plus 28. Missed a 2 there. Plus 35 plus 35 plus 36. Takes me a second. Hang on, guys. Plus 41 plus 41 plus 45 plus 46 plus 49 plus 50 plus 53 plus 56 plus 58. Now, how many data points we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So we got 686 when we added those all together. We're going to divide that by 19. We get 36.1, which is our average score. The range of scores is the highest score minus the lowest score. So 58 minus 10, we have a range of 48. And we can see this was our data points written out in order, 36.1 and a range of 48. The marks across 3 subjects of 5 students are recorded in the table below. Represent this data in a column graph. So we have Fran, Jake, Cecilia, Nancy, and Josh, and they have English, Maths, and History marks. This is what it would look like if we represented it in a column graph, So see how there's breaks between each student, but we don't need breaks between the columns when they're all for one piece of data, which is the student itself. So we've drawn out our marks, which go up by 10, 20, 30, 40, 50. We've spaced out our students, and we've included a key. So English, Maths, and History, and these are their 3 marks. All right, how do we do really well in classifying and representing data? Number 1, double check your axis. Make sure that the correct variable is in each place and you're not using the independent variable on the wrong axis, or you're using the class on the horizontal if it's meant to be on the vertical. Always double check if you need to include a frequency polygon or line, and don't estimate, so do it properly, please. It will save you so many marks. Always double check the data you're given. It is often mixed up like a stem and leaf plot, and it can be misread if you don't put it in order. Okay, what do you include on your summary sheet? Sampling methods, classifying data, and tabular and graphical representations of data. I would say the third point is the one that I see most often tested in Year 12. They're not really going to ask you questions about, is this categorical ordinal or categorical nominal, or how do you classify it, or how do you sample? So how do you, what is a stratified sample? It's very unlikely they'll ask you that in Year 12, very much in Year 11, but not in Year 12. But tabular and graphical representation, so all of that cumulative frequency, relative frequency stuff is very much important to Year 12. Okay, so we're coming to the end of our lecture. We have about 7 minutes left. So I'm going to run through a few more things before we finish. But what have we learnt so far? So today, this is the Year 11 course. We looked at applications of measurement, money matters, and data analysis. Now we looked at 2 portions of applications of measurement, 1 portion of money matters, and 1 portion of data analysis. All right. So this is a question I would like you guys to let me know in the chat. What is your biggest fear or concern as you move through Year 11? So let me know in the chat. I'm going to hit some of the main ones. The first one that I get from students a lot of the time is just failing. I'm scared that I'm going to fail my exams. I'm scared I'm going to fail my assessments. I'm scared of this, and this, and the other, whatever it is. The first thing I can say to that is that fear of failure is not going to, it can be a motivator, but it's not a productive fear, in my opinion, because it's something that you can do something about. You shouldn't fear things that you can do something about. There's certain things in life that you cannot change and certain things that you can change. And how you do this year is something that you have control over, relatively. There are obviously intervening factors like emotional hard times, physical hard times, unforeseen circumstances, difficulties in school, things that may happen to you that you aren't expecting or you didn't think would impact you in Year 11. But for most of the time and for most people, it is pretty much entirely up to you how you do in Year 11. So fearing failure when it's something you can actively control is probably not the most productive thing to do. Easier said than done. What I would recommend is number one, all of the above. You're at the beginning of year 11. You have plenty of time to get good marks. You are not days out from your HSC exams. Not all hope is lost. You are completely fine. You have a lot of time to do well. So how do you avoid failure? Try and keep up to date with your class. Try and keep up to date with the questions you're being given. If you get given homework and there's too many questions, halve it and do the harder questions. Make sure you make compromises with how much work you think you need to do. The next thing is let yourself make mistakes in your year 11 assessment, but do learn from them. So this is the time to do the silly things, the things that you shouldn't do in year 12, like make silly mistakes on your exams or not understand how to write a paragraph or whatever it is. Make the mistakes now, fix them before year 12. Number 3, even if you do fail your prelim exams, it is not the end of the world. Those marks go nowhere. They can help you get into uni sometimes, but they're not going to impact your HSC. They do not have any impact on those final marks. So you can fail year 11 and you can get a 99.5 in year 12. It probably hasn't happened, but theoretically it can. So failing year 11 is not going to end your aspirations of getting a good ATAR in year 12. Now, obviously, try not to fail year 11. It's very hard to fail all of year 11, to be honest with you. As long as you put in these pieces of work that I've described to you today in preparation, in consistency, in discipline, and in paying attention to your content, you will be absolutely fine. In fact, you'll be more than fine. You will excel. Another thing I get a lot of questions about, procrastination. Number 1, if you fall behind, cut down your work to catch up. Don't do everything 100% if you don't have the time to do everything 100%. It's also better to, you can call it half-assed. It's better to do one thing very well than 2 things poorly. So pick one of the exercises and pay a lot of attention to it rather than doing both of them very poorly. The other thing is note taking. Try and do your summary sheets now while you still have time outside of assessments before you get into very heavy prelim periods. So in the holidays, try and do 20 minutes, half an hour a day of your summary sheets. And by the end of the holidays, you'll have 3 or 4 beautiful summary sheets of what you've already covered. You don't have to do any work when you get back. You can jump straight into content. If you do procrastinate digitally, I have a really good app that I like. It's called Forest. It plants imaginary trees on your phone and it grows the tree, and if you leave the app, you will kill the tree. So this month so far, or this week rather, no, I'll do month. It makes me sound more focused. I have focused for 22 hours and 5 minutes on this app, which was actually only across about 4 days that I had midterms. And I planted 43 trees in my beautiful little forest, and you can see a nice breakdown of all the trees you've planted. This was my HSC year. You can see I focused for 50 hours in my HSC year, growing a lot of trees back in 2020, 99 trees to be exact. Now, they're not real trees, but something about the tree growing on my phone actually helps me not go on my phone because I don't want the tree to die. Because then you permanently have a dead tree in your record, and I'm 4 years in with no dead trees. So Forest is a great app. I would also recommend those study with me's and people making videos about study with me, how I study and learning about their techniques. Some of my favorite people that I used to watch in year 12 were Eve Cornwell, Unjaded Jade, and Ruby Granger. I really liked their videos. The other thing is putting someone else on FaceTime while you study. It can really help you in terms of discipline and motivation, because if you see them studying, you'll feel like a bit of a slacker if you're the one there sitting on your phone. The other thing is paying attention to burnout. You have to preempt burnout. You have to know that it's coming and prevent it. How do you know that it's coming? When you start the term, you generally have a little bit of a motivation kick. You feel like you're ready to go. As soon as you realize that getting enough sleep isn't helping you and doing everything right isn't helping you, you're eating right or you're eating well and you're getting a bit of movement in and you're sleeping and you're doing all of that and you're not feeling any better, you are overworked and you need a break. And so sometimes you're going to have to sacrifice certain things like your extracurriculars, or maybe a mark will be a little bit lower because you just can't study, so that in the long term, you don't have that horrible burnout where you lose 4 months of your study, if that makes sense. The last thing I would say is that you should really try and enjoy these 2 years. They are the best 2 years of high school. They're the hardest, but they are the most fun. They are the best. They have the most incredible memories in them. You will treasure it for the rest of your life. I know that not everybody likes high school. If I could go back, I'd probably do about 3 hours before I'd say no, because it is a lot harder than so many other things you get through after high school, like uni. But They are some of the best years of your life in terms of that growing and being with your friends and having such a great time while you kind of all collectively go through this tough experience. The last slide I'd like to give you guys is kind of a little approaching year 11 and 12 thing that I like to show my students. So step 1 is accepting that it's going to be stressful and it's going to be hard. They always tell you like minimize stress, don't be stressed, blah, blah, blah. You're going to be stressed. That's end all and be all. You will be stressed. No matter what you do, you will be stressed and it will be hard, but it doesn't have to dominate your life. So you have to try your best in maths to stay up to date. And when you do fall behind, like I said, it's about learning to prioritize. So cutting your homework in half, only attempt the harder questions, so on and so forth. It's also important to plan revision weeks out from the exam. This is a very aspirational but good way of planning it. So 4 weeks out, you have finalized note. 3 weeks out, you're practicing your exams with no timing and with your notes available. 2 weeks out, you put on a timer and you only have a few notes. And then 1 week out, no notes, fully timed, full exam conditions. This is a good way of trying to be prepared for when you actually do sit those exams rather than only being timed for the first time when you actually sit it. Now, guys, that brings us to the end of our lecture today. We've been here 2 hours. Feel free to drop some really last minute questions in the chat while I sign off. So again, ATAR Notes free resources, go to atarnotes.com/register for all of this stuff. It is amazing. It is so helpful. I would highly recommend you check it out. But more than that, thank you so much for watching. Good luck, guys. You've got this. Hopefully, I will see you back again for our next lecture series. But between now and then, do your best, work as hard as you can or as hard as you want to, and appreciate the time you have in year 11 because it truly should be a good year. You guys have got this. If you've been here, you're already set. You're on the ball. You're focused. Best of luck, guys. Hopefully, I see you next time.